Hi, how is it going? Welcome to Code with Z. In today's video, we gotta see in how many ways we can actually climb a staircase. Why? Well, because that's what LeetCode 70, climbing stairs, is asking us to do. As you can see, it says you're climbing a staircase, it takes n steps to reach the top. So for example, if our n is 2, that means it takes 2 steps to reach the top. And then we see that it says each time you can either climb 1 or 2 steps, basically at a time. So at a time, you can either climb 1 step or 2 steps. And then it says in how many distinct ways you can actually climb to the top. Well, let's see. So we just saw that this n here is representing the number of steps that we need to take. So for example, if our n is 1, so when n is 1, there's only one way. Why? Well, because there's only 1 step and we're just gonna take 1 step and we're gonna reach the top. When our n is 2, there are 2 ways. Why? Well, because we can either take 1 step and then another step, or we could just take a step that's going to be consisted of 2 steps, because we just saw in the slides, as you can see, it said you can either climb 1 or 2 steps at a time. And that's why we have 2 ways here. You got to remember that we're calculating the number of ways we can actually do it, not the steps. We are already given the steps and we got to find the number of ways we can actually get to the top. So now we know when n is 1, there's only one way, and when n is 2, there are 2 ways. What about when n is 3? Well, when n is 3, there are 3 ways. Why? Well, it's pretty simple. From this point on, all that we're going to do is this. We're going to say, well, n is 3, right? If we want to see in how many ways we can actually get to the top when n is 3, we're just going to add the last 2 answers that we had together. So when n is 2, there are 2 ways, that we have 2 here. And when n is 1, there's 1 way, so we have 1 here. 2 plus 1, that's going to give us 3. And that's why we have 3. Literally like this. So each time when n is greater than 2, we're just going to get the 2 previous answers and we're just going to add them together. For example, now we know when n is 3, there are 3 ways, right? So what about when n is 4? Well, when n is 4, we have 5 ways. Why? Well, currently we're calculating when n is 4. Let's see what we had when n was 3. Well, when n was 3, we had 3 ways, like so. And when n was 2, we had 2 ways. So 3 plus 2, that's going to give us 5. And that's why when n is 4, there are 5 ways. Now, what about when n is 5? Now you get the idea. When n is 5, there are 8 ways, because 5 plus 3 is equal to 8. 5 is representing the number of ways when n is 4, and 3 is representing the number of ways when n is 3. 5 plus 3, that's going to give us 8, and therefore when n is 5, we're going to have 8 ways. This is going to be it. Now, let's code this in the simplest way possible. Alrighty, let's code this together. So just like we saw in the slides, we said if n is equal to 1, we got to return 1. And we said if n is equal to 2, we got to return 2, because when n is 2, there are 2 ways, and when n is 1, there is 1 way. And then for the other ones, we're going to use this. We're going to define an array and we're going to call it DP, dynamic programming, for example, because this is dynamic programming. We break down the problem into smaller problems and we store the results, and then we use those results to fix and solve our bigger problems. So we're going to define this array and it's going to have 0, 1, and 2 here, right? And then we're going to say, I'm going to explain this in a bit, don't worry. We're going to say for let I being equal to 3, and we want to keep on looping as long as I is smaller or equal to n, and I plus plus on each round. Here we're going to say dp at the index of I is equal to dp I minus 1 plus dp I minus 2, like so. And then at the end, we're going to return dp at the index of n. Now, what does this mean? Well, for example, if our n that's given to us is 3, we're going to be like n is not equal to 1, n is not equal to 2. So let's define this array that has the answer of n being equal to 1 and n being equal to 2. And then we're going to use these to calculate the rest. We're going to say dp at the index of I, and I starts from 3. So dp at the index of I is equal to the answer of dp I minus 1, which is n being equal to 2. So the answer of n being equal to 2, just like we saw in the slides, plus the answer of n being equal to 1. Now, for example, if we actually have, 5 here, we're going to keep on looping and we're going to add answers to this array on each round until we reach 5. And then we're going to say n being equal to 5 is equal to the answer of n being equal to 4 plus n being equal to 3. Simple as that. And this 0 represents 0 steps. So for example, when n is 0, we're just going to return the 0 that we have here, because here we say return DP at the index of n. This is gonna be it now. Let's run it and see if we're gonna get accepted. And moment of truth. And yep, we got accepted. Let me submit this. So we make sure that we actually pass all of the test cases. Drum roll, please. Just kidding. Yep, awesome. We just passed it. Thanks for watching. Don't forget to like and subscribe and keep on coding.